For this problem, we were given this cubic equation, x to the third minus 4x squared minus 5x plus 1 equals 0. And we are supposed to find one solution accurate to at least 8 decimal places of this cubic equation. Cubic equations are nasty. There is a formula, kind of like the quadratic formula for cubics, but it's really, really long. And trust me, you don't want me to take time in class to go over how to do it. This one, we're going to find an approximate solution using Newton's method. Okay, now the formula for Newton's method is going to be that x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n. That is the formula for Newton's method. And the f in this case would be what I see here. F of x is equal to x cubed minus 4x squared minus 5x plus 1. So if I take the derivative, I would find that f prime of x, so just doing scratch work on the side here, f prime of x would be equal to 3x squared minus 8x minus 5. And so this can be rewritten as x sub n minus x sub n cubed minus 4x sub n squared minus 5x sub n plus 1 all over 3x sub n squared minus 8x sub n minus 5. And I could get a common denominator, but there's really kind of no point for this problem. All right, now we're going to use our calculator to be able to estimate this root to high precision. The way that I will do this is that I'll basically enter what I see here into my calculator. So here's what I will enter into my calculator. It's going to be basically what I see here, but everywhere I see x sub n, I'm going to use the answer button on my calculator, denoting the previous answer. So answer minus, then I have the numerator, answer raised to the third power, minus 4 times the answer squared, minus 5 times the answer, plus 1, all divided by 3 times the answer squared, minus 8 times the answer, minus 5. And so that's exactly what I'll type into my calculator after putting in my initial guess of 5. Okay, so let me do that here on my calculator. And so hopefully this is visible on screen. Okay, so the first thing I do is type in 5. So that's been entered. And then I type in pretty much what I see here. So then I have answer minus left parentheses, answer to the third, minus 4 times the answer squared, minus 5 times the answer, plus 1. That closes the parentheses in the numerator. Divided by, then I have 3 times the answer squared, minus 8 times the answer, minus 5. And so doing that gives me my second guess in Newton's method, which is 4.966667. Now, the reason that I type all this is that if I go now just to hit the enter button or the equals button on your calculator, I then redo that calculation using this new thing as the answer. And so my second approximation will be this. My third approximation is this. My fourth approximation is this. And notice that I'm getting the same answer over and over again. And so that now Newton's method has now converged to the accuracy that I have on my calculator. And so my root will therefore be approximately equal to 4.966250299. Whatever number that appears on my calculator when I get that gets repeated, that'll be to 10 decimal places or to 10 significant digits, the approximate root of my equation. Okay, so that is the fast way of being able to use Newton's method and type that into a calculator to repeatedly use this formula over and over again to figure out what the approximate root is.